Okay, so in our last video, we went over domain and range when it was discrete. Now we're going to go over it when it's continuous. So graphs and data can either be discrete, again, check out the other video if you need that, or continuous, which is what we're doing today. So again, this is great vocabulary if you need that. Continuous data is data that is defined for measured values. So that means the in-between values are included. So stuff that's measured, this can be anything from height or weight, right? That's pretty normal to measure both of those. Really common, we use time, right? Because you could have half of an hour, you could have half of a day, or temperature, because you could have decimals for temperature. And there's a few others you could probably think of off the top of your head. When we're graphing these, we're going to use lines or segments. And the most common ones we're going to see are when we have a line with two endpoints. We've got one endpoint and then one arrow. And then we've got one line, but it has arrows on both ends. All right, so go ahead, you can pick one of these to draw on your graph. I'm going to go ahead and pick the one that has an arrow on one end. Moving on, we have a swimming pool. This has a volume of 8,500 gallons of water. It starts with 8,500 gallons of water. It is being drained, so we are losing water, at a rate of 500 gallons per hour. That means every hour we are losing 500 gallons. Okay, so again, if we're starting, X is always the first column, Y is the second column. At 0 hours, we have 8,500 gallons of water in my swimming pool, right? I haven't turned on the faucet, the tap that will drain out the water. After 1 hour, I lost 500, so I'll have 8,000. 2 hours, I'll have 7,500. 3 hours, we have 7,000. 4 hours, we have 6,500. And we're thinking, wow, I want to find out when my water is going to run out, but I clearly don't have the space for that. So over here, we're going to go ahead and make a new graph, or we're going to continue it. So that means at 5 hours, we'd have 6,000. And we're just going to keep going until we hit 0 gallons of water left. Okay, I'm at 9 hours at 4,000. Okay, I'm running out of space. 16, I have 500, and at 17 hours, I have 0 gallons left. So it takes 17 hours for me to completely drain my swimming pool. So if you want to add on to this one, it's going for 17 hours for me to drain my entire pool. Okay, very cool. So let's label our graph. It is going to be called swimming pool. X is the number of hours according to my table. So we're going to write number of hours. And it says Y is the volume of water remaining. So we're going to go ahead and write water remaining or water left. And this is in gallons. It's important to include gallons because there are other systems like the metric system where they use liters, which is completely different. Okay, again, we start with 0, 0 at the very corner. And since our numbers are getting bigger pretty fast, we're going to go by evens for this one. 2, 4, 6, 8, 10, 12. And I fit all the way till 22. We should only need till 17. And going up the side, because we're all the way in the thousands, I'm going ahead and skip 1 and write my thousands. So 1,000, 2,000, 3,000. So every box is worth 500. So I should be able to fit until 8,000, which is just shy of what I need. So when I'm actually going ahead and graphing, if I'm starting with 0 hours at 8,500 gallons of water, that's going to be right off the charts of the y-axis. Then I'm going to go from there. So at 2 hours, I have 7,500. 4 hours, 6,500. And go ahead and use those numbers we already came up with to draw all the dots on our graph. You can also do the in-betweens for the odds. And because the number of hours is divisible by 2, right? Half of an hour is 30 minutes. We can actually go ahead and connect these dots. But I am not going to draw arrows on the ends, and we're going to see why in a second. So, because I can draw a line, because I can have half of an hour, we're going to write that this is continuous. I'm going to write we can have half an hour. The possible number of hours is our x values. That's going to be our domain. And our domain is going to go all the way from 0, right? Our smallest number of hours is 0 if I don't drain water at all. And I know it has to do with x because it's domain. And the most number of hours would be 17, right? If I drained it for exactly 17 hours, I would have no water left. Next thing is the amount of water remaining is the y value, so that's range. So I know y is going to be in the middle. The smallest amount of water I can have is 0 gallons, right, if it's completely empty. And the most I could have is 8,500 gallons if it is completely full. So this would be our domain and range for this particular situation. Okay, moving on. When analyzing graphs, we give values names to describe them. So the x values are what we call, again, the domain. Range is the name for y values. And when we are writing the domain and range of continuous data, we're going to be using inequalities. Go ahead and pull out a small pencil. For domain, we're always going to go from left to right because the smallest values for the x is always on the very left of the graph, and the bigger values are going to be on the right. For range, the bottom values are going to be the small ones, right? For y, all the way at the bottom. We're going to go bottom to top because our top values are going to be the bigger numbers. Okay, so over here, domain. Again, we're going to have the small number first. And then it's going to go up to the big number. And since it is domain, that means the one that's on the left is going to be the small number. And the one that is on the right is going to be your big number. So range is going to be really similar, except again, we're not going left to right. We're going bottom to top. So when I'm writing this, I'm still going to start with the small number. And I'm going to go all the way up to the big number. But the small number is going to be at the bottom of the graph. And it is going to work its way up to the top of the graph. When you see this less than symbol, you're going to have an open point, right? It's going to look like this. It's going to be an open circle. When you have the little line underneath, it's going to be closed. That little line underneath means you're going to fill in the circle. Okay, so for example, if I'm starting with this first graph, I'm looking all the way to the left of the graph. And I see that this point right here, this end point, is the farthest to the left I'm going to go. So that x value right there is at -1. It's at -1, and that dot is closed, which means we need the line underneath. Okay, then we're going to go ahead and go all the way to the right, which is going to be this bottom point over here. And the x value here is at 5. And again, it is a closed point. It's a closed circle, so we're going to draw a little line underneath. For the range, I'm looking at y values. We're going to go bottom to top. So starting from the bottom, I see that we have the same point over here. But this time we're looking at the y value. The y value for this one is 1. It's 1, and again, it's a closed circle, so we're going to need a little line. Going all the way to the top, I have this point that we started with originally, and the y value here is 7. And again, it's a closed circle, which means we need a little line underneath to say that it is a closed circle. Okay, over here, again, we're going to go left to right. All the way to the left, we have this point, and the x value here is at 0. Since there is no point, there's no dot here, I had to draw it on, that means it is closed. If there is no point, that implies it is closed. Okay, going all the way to the right, I have this point right here, which is at x equals 8, and again, it is closed, so we got a line. Next, for the range, we're going to go bottom to top. So starting from the bottom, that bottom number is at y equals 0. It's closed, so I need a line. And I have to go all the way to the top of my graph, which is actually at the vertex of this quadratic, or this parabola. And the y value here is at 150. Again, since there is no dot there, it is going to be closed. Our next example is a weird one because it has arrows. It means it goes on forever. So if I'm going to do what I was doing, start all the way from the left, go to the right. On the left, it looks like because of this arrow, it's going to keep going forever negative. That means I go all the way to negative infinity. Looking at the right, this is going to keep going as well. So I'm going all the way to positive infinity. Right, since this is not a specific number, infinity isn't really a number, we're going to leave the symbols the way that they are. Next, I'm looking at range, bottom to top, and it looks like, again, this arrow is going to keep going down forever, so I've got negative infinity, and it keeps going up forever on the other end, so we're going to positive infinity. This situation is what we call all real numbers. Or short would be ARN. The reason why we call it this is because, for example, for domain, it is going to hit all of the numbers forever negative and forever positive. So it's going to hit all of the numbers. So you would say, hey, my domain is all real numbers and my range is all real numbers. Okay, this last example for this type, let's go ahead and start from the left. We're going to go to the right. All the way to the left, I have this point, and it's open, so keep that in mind. The x value here is at -4. Since it is open, I am keeping this symbol. I like that symbol. All the way to the right, I have this open circle. This is at 5. 1, 2, 3, 4, 5. Since it is open, I'm going to leave my less than inequality. That's perfect. For my range, we're going to start from the bottom, and the bottom point is down here, again at the vertex of your parabola. The y value is -2. Since there is no circle here, I had to draw it on. That means it is closed. Okay, going all the way to the top would be this point up here, and the y value here is at 5. So this is going all the way up to 5. And this one is open, so I'm going to leave the inequality the way it is. Okay, so if we put this into practice with a word problem, let's go ahead and underline some things that are important. First of all, I see that Sandy is measuring the height in inches of her roses. This is important. She discovers this formula. That's nice. And X represents the number of days. She's going to measure between 4 and 8 days. And they're asking what is the range. Because 4 and 8 days is the domain. You'll see why in a second. So, first of all, let's write the variables. X is the number of days according to my word problem. It did not tell us what Y is, but I know that she's measuring the height in inches of her roses. Okay, so we're going to write height of roses. This is in inches. This is important because we don't want to measure in feet or centimeters or meters on accident. Okay, and because days, the number of days can be split into two, right? You could have half of a day. This would be continuous. We're going to write can have half a day. And we are going to go ahead and use Desmos to make a graph for this one. How we're going to do that is we're going to use this formula that she has given us. Okay, get rid of some of my old formulas, and we're going to go ahead and plug in this formula that we have. Got f of x equals 5 plus 0.25 x. And we're going to look at it in a second. I'll make it bigger. But let's go ahead and take a peek. Our question is asking for range. And specifically, we are looking at one part of the graph. We are really looking at where 4 days is less than x is less than 8 days. Because we're looking at between 4 and 8 days. And we said x was the number of days. So we're really looking at where x is between these two values. So I'm going to go ahead and graph over here. X equals 4, because I want to see where it's going to start at 4 days. And I'm going to graph x equals 8, because that is the last day that we want to look at. Let's go ahead and make this a little bit bigger so we can look at it. Okay. So where these cross our line is the height of roses at that time. Right, so at 4 days, your roses are 6 inches tall. Okay, and then at 8 days, they are 7 inches tall. So that means the range between 4 and 8 days is going to be 6 to 7 inches tall. And this would be your answer. We're going to go ahead and zip through this last one really quick. Farmer John has 500 feet of fencing. He uses this formula. He knows that the width is x and the length is y. We are looking for the domain, so we're looking for x for the situation. I know that x is width. It is in feet. And I know that y is length. Also in feet. I would say that this is continuous because you can have half of a foot, and we're going to go ahead and use Desmos again to graph this. Something to keep in mind is that since we're looking at domain, we're looking at all the possible widths for this garden, right? And it would not make sense, so we don't want to have 0 feet for width. Or length, right? We can't have your garden have 0 feet for the width or length. That means the whole thing would just be one stretch of fencing. So we can't have that. So keeping that in mind, let's go ahead and graph our new function over here. We have 2x plus 2y equals 500. Okay, let's go ahead and zoom out so we can see everything. And it looks like it goes from there to there. My domain, remember my domain is all x values. And it looks like my x values go all the way from 0 to 250. And I am only going to write less than, because if I write less than and equal to, that means I'm okay with having 0 width. And that doesn't make sense. So we're going to go from 0 to 250. And your statement would be between 0 and 250 feet. And that would be it. Congratulations. That is it. If you'd like to go ahead and work on some of these other problems on your own, feel free to do so, but thank you for watching.